Sure.
Welcome everybody. My name is Jonathan Backrack. This is a panel on language design, and it's sponsored by the Dynamic Language Group. This is our website here. We have a number of events. This is the third panel of three. We had one on runtime compilation. This is the language design panel. And you can see the movies through this website. They're electronically stored, and we're broadcasting this live today, and it'll be viewable later as well. This is part of the 6.894 seminar that's taught by Costas, Greg Sullivan, and myself. And we are covering the material of advanced object-oriented dynamic language design and implementation. And this panel here is targeted towards grad students at large, and specifically at MIT, and even more specifically in our class. And it's meant to help them come up with research ideas and emulate these illustrious panelists here. So we're going to have this, the panel is going to be divided into two parts. We're going to start with round robin questions that we've prepared ahead of time and given the panelists time to consider. They'll have 2 minutes per question. And then finally we'll open up the questions to the audience, and we'll give priority to grad students first, then we'll open up beyond that. I'd like to say that I'm just completely thrilled by the panelists agreeing to come. We were very lucky here to have these four people. I can't give a full account of their great careers. I'll just highlight them. First, I'd like to introduce Paul Graham. He most recently worked for Yahoo Inc. Previously, he was president of ViaWeb, which became Yahoo's store when ViaWeb was acquired by Yahoo in the summer of 1998. He has also written a couple of books on Lisp and has been thinking about language design issues. Next, I'd like to introduce John Maida. He is Associate Director of the MIT Media Laboratory, where he's also a Sony Career Development Professor of Media Arts and Sciences. He's the author of 2 books, Maida at Media, a 480-page retrospective of his decade of experimentation in new media, simultaneously published in 4 languages, and also Designed by Numbers, an introduction to programming for the mathematically challenged. He is the 1999 recipient of the prestigious Daimler Chrysler Design Prize and numerous other design awards. Notably, Maida was undergrad and grad in Course 6. I'd like to introduce Jonathan Rees now. Jonathan's interest in programming language goes back to his discovery at age 13 of XPL, a so-called compiler or parser generator. In high school, he was writing his own compilers in Snowball 4 at Yale. Drew McDermott taught him APL, Prolog, Simulus 67, Lisp, and Scheme. He wrote T, the first compiler-based Scheme implementation, in 1982, and edited the 3rd revision of the Scheme report in 1986. He was a consultant to the DEC Common Lisp product group and to Chestnut's Common Lisp to C translator effort. At MIT, he was a TA for the graduate course on programming languages and wrote a dissertation on secure programming languages based on Scheme 48 system he has been developing with Richard Kelsey for almost 15 years. At Cornell, he turned his attention to how robots might be programmed, and at University of Sussex, he looked at how animals might be programmed. Most recently, he has been working on various distributed systems, including a social virtual reality system at Trenza Corp. He is currently unaffiliated. Guy, I'd like to introduce Guy Steele. Really happy you're here. I can't even do a tiny. I can only do a tiny fraction of his his great career. I'll start by saying that he got an AB in applied mathematics from Harvard, PhD in computer science and AI at MIT. He was an assistant professor of computer science at Carnegie Mellon University, senior scientist at Thinking Machines Corporation. This is just sampling. Author or co-author of numerous books on computer science, including books on C, Common Lisp, and Java. Author of 24 papers on Lisp language and implementation. Served on numerous language standards committees, including C, Fortran, Common Lisp, and Scheme. Winner of numerous awards, including ACM and AAA Fellow. Currently working for Sun, responsible for research in parallel algorithms, implementation strategies, architectural and software support, and for the specification of the Java programming language. Thank you very much for coming. So we'll start off with questions, and Paul will give each the panelists 2 minutes per question, and we'll start with your guiding philosophy.
Me?
Yeah, and
Guiding
you're on,
philosophy.
Paul.
All right. By the way, Guy Steele has designed all the languages, and I have designed none. So if he and I seem to disagree about anything, he's probably right. You guys, can you hear me in the back? Even now? Can you hear me in the back now? All right. Loud it is. So, guiding philosophy. I think, one, programming languages are for people. If you think what a programming language is for, it's for telling a computer what to do, right? I think the computer would be just as happy talking in any language as long as it was unambiguous. So who's the programming language really for? It's for the person. I think the entire point of programming languages is to save our weak human brains from being overwhelmed by a massive detail. And this makes designing programming languages different from designing other kinds of software. In designing, in the world of architecture, designing bridges, for example, is very different from designing chairs. Designing bridges is a fairly nice impersonal problem of spanning a large space with not too much material, whereas designing chairs requires the designer to be sort of intimately acquainted with and always thinking about the human butt. And so people who design great bridges don't necessarily design great chairs, although they try. Programming problems are like that too. Some problems are a lot more about people than others. Designing algorithms for routing data around a network is a fairly nice impersonal sort of problem. You may deal with outages, but you don't have to deal with personal idiosyncrasies. Whereas designing programming languages, the whole purpose of programming languages is to support personal idiosyncrasies, like it or not. This doesn't mean you can't design languages that are mathematically elegant, because mathematical elegance, some kinds of it, make programming languages easier for people to understand. But that is not the raison d'etre of programming languages. It's just a help in having a good one. How much time do I have left?
Like a minute.
A minute, all right. I'm going to blow through the other points. I hate when people talk too long. So, number two, I think it's a good rule of thumb probably to design a programming language for your own self to use rather than for other people. I've been thinking about this, and it seems like a lot of the best languages were designed for people to use themselves. And a lot of the worst languages were designed for other people to use. And that's because when programmers design languages for other people to use, it's always a specific kind of other people they have in mind. Other people who are not as smart as the language designer and need to be told what to do and prevented from getting themselves in too much trouble. Right? And hackers especially do not like to be told what to do. They like to sort of mess around with things. I think it would be an interesting approach if just for once language designers tried to design a language that was for people smarter than them, right? Like they just have this small conception of what ultimately fabulous things these programmers might want to do with this language, and they better just get out of the way and let these guys have control of everything. So, number 4, aim for brevity. That was 2 and 3 combined. Brevity is underestimated and even scorned, but if you look into the hearts of hackers, you find that they really love it. How many times have you heard hackers speak fondly about the amazing things they could do with just a couple lines of APL, for example? And I think that anything that really, really smart people really, really like that much deserves paying some attention to. And I think it's probably worth, just as a little experiment, to just see how brief you can make everything. And I think, in particular, you should try and make the description of the language be brief. If you forced yourself never to let the language description be more than, say, 150 pages, you'd find, as you were having to write the description, that, you know, you get to some page where you have to give like a page of qualifications and warnings and caveats and special cases. You know, if you didn't have room for that page in the manual, maybe you'd have to go back and redesign the language to make it simpler so you wouldn't have to give all these explanations. 5, admit what hacking is. I think a lot of people wish that hacking were mathematics or something like a natural science. I think really it is its own thing, and it's something closest to probably architecture. Architects have to know about physics, or at least have to know engineers who know physics, so that their buildings don't fall over. But they're not doing physics. They're not like inventing some kind of thing in the natural sciences. They're just trying to build great buildings. And hackers, like, they don't get rewarded for making great programs. And I think, you know, you don't get tenure for it anyway. You have to like write some great program and then make up some paper about some little thing you discovered in the process of writing this great program so you can publish a paper about it and get out of grad school. I think, at least amongst ourselves, we ought to admit that it's a great thing to write great software, even if no one will give us tenure for it. All right.
Okay, the air conditioning's on, so we got to keep the voices up. Can people hear? Okay. Really boom.
Okay, yell.
Maybe stand up.
We can't, it turns out we can't use an amp or speakers because feedback in the system, so we just have to use...
Right, standing up.
Okay, stand up, that's a good idea. Do you mind? Okay.
He's wearing shorts.
Really haven't prepared for this. Yeah.
Shield your eyes.
So Paul has all the answers, and I just have questions. I guess I find this business very interesting. You know, in the 70s and 80s, we had this sort of dream that, you know, if only you could come up with just the right language, and just the right implementations, then it would sort of take off, and it would be used for all applications, and as your shell command language, and as your scripting, and for scientific computing and high performance stuff. And so a lot of people put a lot of effort into universal languages, and I think it's very mysterious that with so many smart people working on it, that hasn't happened. And I don't know that I have an answer there, but you still can't hear. I don't know that I have an answer to this question of the continuing proliferation of languages, but I think it's a very interesting sort of meta question about this field of endeavor. You know, we still have, you know, multiplication of languages with sort of a major language coming out every year or two, it seems, and no sort of consensus or you know, commonality between them. So languages are proliferating. Languages are programs, after all. They are, in some sense, they are their implementations, and so they're programs, and there are lots of programs, so you might expect there to be lots of languages. So maybe this is natural, but it still seems odd and interesting. If you're designing a language, you want to think about the audience, and you know, if we're 1980, you would think that your audience was everyone, but I guess this. Well, one thing I worry about is do programmers really care about the language they use? Right? People want to solve problems. Typically, I'm talking very generally here about, you know, to the extent I can, about what I perceive as the kind of the biggest market for languages, and they'll use whatever language is going to solve their particular problem best at the time. They may regret a language choice a few years down the line because it prevents growth, but you know, if this language is very good for image processing, they're going to use it, even if they, you know, it doesn't matter what they think about Scheme or Python or you know, Prolog or anything else. They don't have a choice of what language to use. They need to use the one that's best for their application. So that's kind of another sort of mystery, that the proliferation is really a proliferation of libraries and of applications, and the languages are almost like the tail being pulled along behind the applications. So, you know, guiding philosophy, I guess I have a few short ideas to toss out here. My ideal for programs and for languages is that they, you know, we talk about modularity and as some sort of ideal, or, you know, simplicity or parsimony or something like that. And the way I've been thinking about it lately is that you want your programs and your language is to be rewritable, right? You know, a program that's simple enough is one that you don't need, right? It's one that has produced such an amount of understanding in the general population that anyone can take the ideas and reproduce the program from those ideas. So that's what I mean by a rewritable program. And an example of a rewritable or re-implementable language, which I think is a good property, I see that happening with Scheme, which has, you know, high school students going and implementing it, you know, in a week or something, with 20, 30, 40 implementations that you can find just on the web. And I see it happening to some extent maybe with some of the other newer languages. I don't know much about Python, but I see Python coming along, and sort of a variety of Python implementations and dialects. That seems somehow good to me. I'm probably out of time, so I should go on. So I should, yeah.
Okay, Guy.
Okay, well, Paul has already mentioned what I consider my first and foremost point, which is that a good language should be simple to describe. And the main point of this is that you want to be able to keep most of it in your head. Every cache miss you take in order to pull the reference manual from the shelf is a loss of productivity. So you want to keep the language small enough you can keep most of it in your head most of the time. Now, I had the chance to help write the specification for the Java programming language, one of the books I've written. And by the way, you can actually count all the books I've written on the fingers of one hand. Now, it's kind of you to describe 5 as numerous. I guess 5 is a number, but it's actually a small number. And I was brought in not as a designer of Java, but as a biographer of Java. And my principal contribution to the language was that as I was writing the specification of this language, I would constantly return to James Gosling and say, well, I could describe what you did in 20 pages, or you could make the simple change and I could describe it in 2 pages. Which do you want? And once or twice he pushed back, but usually the simplification went through in that last year before the book came out. And I think that really helped the language a bit. For example, the rules for resolving overloaded methods used to be a lot more complicated until we made the primitive types behave more like objects in that respect. It's important to establish design principles early on. That is, in fact, to do meta-design. Because as you evolve the design, or as the language grows later, you want to remain true to an initial vision. This, again, has to do with keeping the description small. And if you can resort to a meta-principle to help you resolve a particular design decision, it keeps the language more consistent. A good example of this is you might decide early on that plus and times are going to be associative and commutative, at least as much as possible. This got broken in a bad way in Java. If you add the string foo to the number 2 and then add that to the number 3, you get foo23. But if you add foo to the sum of 2 and 3, you get foo5. You know, so that's a very bad breaking of associativity. One should strive for completeness and orthogonality. Again, these are consequences of simplicity. If you've got 5 different features of your language and they each have binary choices, that ought to make 32 combinations. If you've implemented only 23 of them because the other 9 turned out to be hard for obscure reasons, then the design of the language is going to remain obscure to the user. He's constantly going to be thinking, well, gee, is that particular combination supported or not? You know, avoid that kind of thing. It's important to consciously separate language from meta-language. It's great to have a language be its own meta-language. You also need to be clear on where the boundaries of separation are and when you cross that line. I've seen a lot of really badly structured Lisp programs written that used eval all over the place where they really didn't need to, but it seemed to be a convenient thing to do. And the problem there is it was crossing the line between language and meta-language in unpredictable ways, which made the program harder to understand. It's a good idea to avoid special cases, but on the other hand, common things should be easy to say. A simple example is the for loop in C or Java. Now, in fact, that's a very general mechanism, and there's an even more general version of that for loop in Common Lisp called the do loop. And yet, about 95% of all the for loops that I see in C or Java are counting I from 0 to n-1. And that gets expressed using a standard idiom that you have to write over and over and over again. It's easy to mistype a character and get it wrong. There are advantages in having a few special case constructs to cover the very common cases, make them easier to write, but more important, harder to screw up. So Common Lisp, for example, provides things called do times and do list that capture the very common idioms. I think it's an important thing that when you design a piece of a language that does a familiar thing, that you do the familiar thing exactly or else stay well away from it. But don't get really close to the real thing, but at least something that's slightly different to trip up the programmer. A very prosaic example is the division operator. I think it's criminal nowadays that you can write 1/2 in a programming language and get a value that's nowhere near 1/2. This is bad design. Finally, part of my philosophy is to experiment with language and to play with it rather than trying to design it all on whack. I try to build a small interpreter and try it out. And it's important to try out the language on real applications in the intended application area. It's a really bad idea to make the compiler for the language be your big test case, unless the purpose of the language is to write compilers. But if it's not, then you should build programs that are larger than your compiler to try it out in a real application area.
I'm using a overhead projector technology. I'm not sure it works. It works. Okay. Well, I come from the viewpoint less of designing computer languages, more perspective of what's the cultural role of the software in design. And in regards to guiding philosophy of where I think that sort of is supposed to be situated, is what does it mean when something is happening in the computer? How do you make more people aware of that? I think the best example I could think of actually recently was back when there was the TI Explorer list machine. It was very noisy, and it had a particular sound when mail came in. Because it sensed something was happening, you knew exactly what it was. And I had the same experience at the Museum of Modern Art, where my group was building something there for the exhibitions. And we had a small table about 3/4 of this size. And there were 6 just top really ace hackers building something there. And the installation guy comes around and says, are they browsing the web? So they had no sense that there was all this stuff being built here. Now just the bridge, the architecture was being built there. But that whole world is invisible. And I find that very lamentable. In general, I'm very interested in how do we somehow situate the act of working in this very invisible domain into onto the same level of culture as, for example, oftentimes you can say, like, I'm a writer. I write books. I made a novel. They say, oh wow, great. Or like, I'm a painter. I made a painter. They say, wow, you can build this thing of this guy all messed up, whatever. They say, oh, I wrote Mac Paint or something. And they say, oh, people actually feel sorry for you, it turns out. An issue that's a very underlying something. I'm not sure what it is, but I know that there's a very famous prize called the Pritzker Prize in architecture. And they make train stations and airports. And oftentimes I wonder, just like Paul, why isn't there some kind of cultural sort of value for that person? And finally, one thing I'm very interested in is how do we get, more people that are interested in the design, not particularly of the semantics of a language, but how it sort of feels. And the analogy I can give you there is oftentimes when we think of like something like a flatware, silverware, there's a lot of silverware out there. It isn't like 5 of them. It isn't like 1,000. It's like millions of them out there. And so you have a lot of choice. But out of that choice, there's some very good ones, very bad ones. Good to hold, bad to hold. And I feel that in the area of at least computation, the varieties are great. There's nice handbooks on the latest languages, but there's a certain missing aspect of how we sort of feel about those languages.
Okay, we'll move on to question number 2, and we'll start with Jonathan Reese this time. Open problems, future directions.
Could I ask a meta question? Is anybody able to supply a 2-sentence, perhaps, definition of what is not a dynamic language?
Well, anyone wants to take that on?
Do it the positive way if you prefer. What is a dynamic language?
Well, I'll leave that to the panelists to take on.
Fortran is not, probably.
Fortran is not.
It's you know one when you see one, but
It's getting fuzzier.
I'll offer one. A dynamic language is one that defers as many decisions as possible till runtime. Not always. It's under the control of the programmer. The programmer might choose to have some decisions made at compile time. But the idea is to defer as many decisions, for example, about array size, about number of data objects to allocate. There are all kinds of decisions like that. The concept is deferring until runtime. That's what I understand by dynamic.
Good, thank you.
Okay, great. Jonathan? Open problems, future directions?
Right. And we're going to continue standing up, right?
Yeah. And booming your voice, too.
Yeah. Let's see. I guess I already mentioned one. I mean, you're talking about potential research topics. I think there's room for a lot more sort of empirical work about how programmers actually work and how teams or individuals make decisions about what language to use. You see some of that, but I think it's just in the literature. It's just sort of the tip of the iceberg. I think most of the rest of what I have to say is sort of is motherhood. I mean, they're clearly distributed computing and cryptography and security issues are sort of at the front of a lot of people's awareness and minds, and these things have had not a lot of impact. I mean, people have been thinking about programming languages for distributed systems for a long time, but I think that's potentially a very hot area. Related to this is, I'm thinking back to Mike Dixon's work on, he was arguing that programs typically, and the languages that you write programs in are talking about entities that are inside one computer, inside the computer's address space. And the implementations are very poor at supporting the notion of objects or activities that are going on outside the direct control of the program. And his example was all of the bugs in the Macintosh operating system having to do with the use of floppy disk drives, because the language didn't understand that there was this floppy disk that a user might actually remove from the drive, and so the programs ended up being full of assumptions that the same disk was in there, from one moment to the next, and you end up reformatting your system disk because you had to put it in order to get the reformatting program, things like that. So the relation between that and distributed programming is just the idea of objects that you have some control over because you can talk to them, but there's some constraints on them because they have predictable behavior, but they're sort of outside of the program. So if I'm trying to get people to do research on particular topics, it's something I want people to look at. So right, and the notion, this whole thing about security, we see this big tension between objects or object-oriented systems and distributed systems, because in a distributed system you have parts of a program, it's a single distributed program, if you will, that are trading information. They don't trade objects. You can't send an object. An object is here, and it has state. If you're lucky, you can sort of pretend that an object can move, but that's just smoke and mirrors. So the notion of an object is something which has state, or is a simulation of a real-world object, or a representative of a piece of hardware or something, it seems to me is a very different, metaphysically different kind of thing from information. And distributed systems are about information because they're sending information around. Information is interesting because you can do all kinds of things with it that you can't do with objects. You can encrypt it, you can copy it, you can compress it, you can cache it, and these seem like really basic ideas, and I don't see them. I may be missing some relevant research here, but the closest you come to this is languages that have an explicit notion of a value that's different from an object, like Pascal, right? And languages like functional programming languages, where all you have is values, all you have is information. There are no objects. There's nothing that has state. I pulled a fast one here because I made this implicit assumption that objects are things that have state. I guess that's subject of another rant about how poorly defined objects are, poorly defined object-oriented programming is. But I think I've used my time.
Okay, great. Thank you. Big guy.
Okay, the first open problem that leapt to mind is not actually a language design problem, but an enabling technology, and that's garbage collection of terabyte heaps and up. We're trying to tackle the garbage collection at the gigabyte and 10 gigabyte level now, but that problem is only going to get worse. And it may be that garbage collection is the wrong idea to begin with, I'm not sure. Another important open problem is finding a good model for parallel programming for multi-threaded systems, and in particular a data model for using in parallel programs. Should we use shared data, messages, monitors? What should it be? Java at least tried to put forward a particular model and tried to nail it down in great detail. Turned out to be a lousy model in a number of ways, but at least it's well specified enough that we get a reasonable amount of portability in using it, which I think was an advance. William Pugh down at the University of Maryland has been spearheading an effort to try to clean up some of the poorer parts of that specification, but I think an open problem is trying to come up with a really good specification for parallel programming. I'm also worried about the robustness of multi-threaded systems. How do you deal with pushing a computation forward in the face of the fact that components may disappear, or things may fail, or the floppy disk might get pulled out of the drive? How do you design software and design languages to support software that are robust in this way? Finally, I'm interested in designing a language that scales from 10-line programs to 10 million line programs. From scripting all the way up to super large systems that run corporations. And I think you need to design a language to do that scaling, because in the small, programmers won't put up with all the overhead you need in order to make a large system robust. So how can you make those robustness features optional in a way that they can enter smoothly with appropriate defaulting at the small level, but be incorporated as programs grow large? I'm not quite yet sure how to design such a language. I think it'd be a good thing to do.
John?
Sorry about this. In terms of some open problems I see, at least in my relationship to computers and software design, I think that we rely a lot on these little ASCII things. You sort of put them together and we try to figure out how to make them into something. In many senses, this thing you might see here, he's a tortured A. He's been tortured and warped and everything. And he's kind of an A, actually, but he's not really an A. But he's kind of a slippery A. You can look at how to hold on to him in different ways. And there's a lot of meaning that comes out of that basic abstraction. And I'm wondering, how do we take that kind of information into the language space? An example, I had an exhibition last year in New York about, I made these objects out of white and black paint, essentially. And I wondered, well, what is this? And so I made some pieces of software on Palm Pilots thinking, well, what is this? And so trying to sort of think about how to think about something abstract in an equally abstract way. Other thing is sort of the reverse. How to sort of get away from being a robot. I mean, every time I sit down to write code, it's like the scene from Matrix where the guy says, I need guns, lots of them. And then all the shit comes out. Because you know you're going to have to walk all the way to the other side to get there. But you prepare yourself. And there's something about, why can't we just sort of throw ourselves at it in a more full-bodied sense? It bothers me. The third thing is how to get more sort of information beyond the symbols in the system. Example is my 3 daughters play violin, and they're still small, and so I got to hear all this stuff every day. But the one thing I hear is my wife saying, all these words, allegro, all these kind of like fortissimo, all these. And so, in many senses, I realize that programming in general is actually like playing the electric piano. The A is everybody's A, it turns out. We mess around with the pitch here and there, we get a little originality, but there's no there's no sort of a human intention in there. So a strong sort of aggression that you can leave there, and perhaps leave a kind of an overall structure that has a greater opportunity for human brilliance.
Paul. All right. How many open problems? 4 problems that I currently worry about. One is how to organize big libraries, because as someone you pointed out, libraries are getting to be so big, and they're so important in how people decide what language to use. Shout! Libraries are big! I have just one word to say: plastics. Libraries. Libraries are big, but as libraries get bigger, you get to the point where it can take longer to find what you want in the manuals than to just write it yourself. And I first discovered this surprising thing when I first started using the Symbolics list machine, which had these manuals like the documentation for a nuclear power plant. I know, because my father designs nuclear power plants, and this is only the second time in my life I had seen such a long series of documents. It is about the same size. How do you organize these gigantic libraries? Ideally, like Guy said, you should be able to guess what library call will do the right thing, and it'll work. 2, are people really scared of prefix syntax or not? This is an open question. I actually worry about this all the time. I don't know. I mean, people say that they don't like Lisp because, you know, it doesn't talk to the operating system, or they can't hire people who are programming in it. Maybe it's just that they're terrified if they look at the program and think, whoa, my God, you know. I don't know, and it really matters. I'm not sure what to do about this. Number 3, this is a more serious one. What do you need in a programming language to support server-based software? I think a lot of the exciting new applications that get written in the next couple of years, like maybe the next 20 years, will be strictly web-based applications, programs that sit on the server and talk to you through a browser. What do you need in a programming language? Huh? Sorry? Shouting. What do you need in a programming language to support applications like that? Well, one thing you need is support for a different model of releasing, because the way server-based applications get released is as 5 to 10 small changes a day, not one great big bowel movement a year. And so, you know how when you have big programs, you can often design software to be debuggable. You also can design software to be changeable. And it would be a good thing if programming languages had support for that kind of thing. What the hell do I mean by this? Well, let me give you an example. Keyword parameters. Who would have guessed it? But it turned out keyword parameters were a huge win in designing ViaWeb, because if I had some piece of software that I wanted to change, I could just add a keyword parameter, and if I only changed the code so that it depended on the behavior of the new keyword parameter and everything else stayed the same, I knew I wouldn't break anything. And being able to tell what's going to break stuff and what's not is really important. Being able to partition your application between stuff that you can change easily, no sweat, and stuff you really ought to think about before you change, because you're going to be changing stuff a lot in server-based applications. Another thing, believe it or not, I think continuations may have a comeback here, because I'm not sure about this. It's still an open question, but one thing you really want to do in server-based applications is use something like closures to keep states, so you can get the effective subroutine-like behavior. The way we did it was to fake. I've made a whole career out of faking continuations by making them out of closures, and so we just did that because that's what I do in every program I write. It might be useful to have actual continuations if it didn't cost too much, and that's an open question. Number 4, this is just something that's always running like a background process. What new abstractions are left to invent? This is almost like asking, okay, you know, what's the next model of physics? If you could answer it, you'd just be automatically famous. It doesn't seem like new abstractions get invented all that often, but it sure would be fabulous if there were some left to invent and one could think of them. All right.
Okay, we're going to go on to question 3, little-known secrets, and we'll start with Guy Steele.
Okay, little-known secrets. Stacks are overrated. Garbage collection is good, but finalizers are bad. Actually, there is a way to give finalizers a reasonable semantics, but it involves doing a garbage collection at every pointer alteration. So if you can only make garbage collection cheap enough, I've got a semantics for you. Lexical scoping is good, but it's very easy to screw up, especially when you're building an interpreter. It also can interact in surprising ways with other features. For example, when inner classes were introduced in Java, suddenly the rules for name inheritance began to interact with the names for lexical scoping inheritance, and some arbitrary decisions got made that I think are perhaps best described as confusing. Type inference can be good, and it's worth studying the languages ML and Haskell, for example, to see how that can be done in practice. But it turns out that error reporting is hard. If the type is inferred and it doesn't match, you end up with 20 pages of type dumped at you by the compiler. And so it's also good to be able to state types explicitly so that the error messages can sort of have pegs to hang on. Monads may be very good. That's still a topic of research I think it's worth studying. Go to www.haskell.org if you haven't already and study the Haskell language. It has a number of very interesting ideas in it. Finally, higher order functionals I think are underrated and can be very good. As the years pass, the more I use Common Lisp, the more I find myself using the sequence functions, including a lot of map cars. I had to do a matrix tensor product routine about 2 weeks ago, and I was puzzling over how to do the nested do loops and so forth, and finally I realized it was just map carve, apply, append of map car, and map car done. You know, it's, no big deal. In other words, thinking in APL can improve your Lisp code.
John?
Secrets. I think one secret I've discovered is programming is boring. Now this actually comes from my discussions with my esteemed colleague at the Media Lab, Professor Brian Smith, who's an expert in media, movies, and critique. And he knows Java with QuickTime. He says, if I have to do another import QuickTime.component.movie, whatever, he says going crazy. And I understand that craziness. On the flip side, if we think, what happened if it made it easier for us, we'd have like the paperclip guy would be in like Code Warrior or something. And like, I see you're making a compiler, Okay. That's the right way. And just as being said about the Lisp machine manual issue, Lisp machines, I remember when I learned C, I had their K and R, it was about this thin, and it was like, wow, if I just read this book, I'll understand C. It's a hard book I actually bought Harvesting and Steel to fix the problem. But it's like this now, and when we think Lisp machine manual was big, all the different ones together. When I tell my student now, I said, Lisp machine manual, we had tons of manuals. And the guy said, Sega Dreamcast manuals. Look at this, And so it's a different scale as well, sort of concerning. And another secret that I discovered while teaching here at MIT, kind of a fundamental concern I have is that there's a kind of an opportunity now that's happening where there are people who are sort of crossing into this sort of quasi art and technology, people who are very good computer scientists but also have a very artistic sort of attitude, and vice versa. And I've discovered that in general, in the general population, in perhaps 1,000 artists and designers today, you can find at least 70% of them that want to learn how to code. On the other hand, you can have 1,000 sort of software people, or maybe 3 or so, want to understand design. I find this very lamentable. However, the good news is that it turns out it's okay, because even if you have a lot on both sides, it all sort of evens out, because only a few people will actually last on both sides. Thank you.
Doesn't Guy have to start this time? Oh, no.
Yeah.
Right.
No, we're continuing with number 3.
Number
Little known
3, little known
secrets.
secrets. Little known secrets. All right, little known secrets. 5 little known secrets. This first little known secret is a little known secret for applications programmers, but it involves programming languages. Can you hear back there? All right. This is sort of a little known secret. To write applications, at least on web servers, you can actually use whatever language you want. And this did not used to be true. I mean, I feel like just telling everybody, you can use whatever language you want, right? Even Lisp. Because that did not used to be true. It used to be writing applications meant writing applications to run on the desktop, and it was real convenient if you used the same language the operating system was written in, or it++. And so there got to be this tradition, right, that you better not use a weird language or you'd get into trouble. And this tradition even penetrated as far as managers and venture capitalists, where it's still very much alive. However, it's just not true anymore. You'll find all kinds of excuses, why you shouldn't use weird programming languages. Oh, no one will want to buy us if we use a weird programming language. Well, no one will want to buy you if your competitors beat your ass too, right? Don't worry about second order problems like whether somebody will buy you or not. Just use the best language you can get and write the program that will beat all your competitors, and then worry about whether somebody will buy you or not. Number 2, speed comes from profilers. I've found this in my own life. Compiler designers like to write compilers that generate fast code, but compilers that generate fast code is not what will make your programs run fast, as Knuth can tell you and everybody else, since programs have a few small bottlenecks, and you're probably wrong in your guess as to where they are. And so you need a profiler to tell you where they are. The way you get fast programs is to have a really good profiler that will tell you what parts of your code you need to rewrite. It's not a matter of making a given program run fast. It's a matter of figuring out where you need to change your program in practice. So I would spend a lot of effort on writing really good profilers and not so much on generating super fast code. Who cares if you declare the type of everything in your entire program? So let's see. Number 3, Guy Steele already said this. You need an application to drive the design of your language. And I would add, like he said, what he said, Great Art used to say, the application shouldn't be just the language you're writing. a lot of the best applications seem to have been, a lot of the best languages have been designed by people who were really pushing to develop a particular application, including Lisp. McCarthy was so excited about doing symbolic differentiation that he started doing it even in the first paper about Lisp back in 1960. It's like, okay, we got a language, great. Here's how we start writing symbolic differentiation programs. He hadn't even defined mapcar yet. He was still using map list, right? But that was enough. Number 4, a language has to be good for writing throwaway programs, because I think that's where programs come from. It's too terrifying to think of making a great big program. And so I bet if you poke around and look at where programs have come from, they've come from some throwaway program. Some languages even have come from being throwaway programs. And so you better make a language that's good for writing throwaway programs, because that's where programs grow from. That's the larval stage. Number 5, this is a shocking idea, and I'll blame it on someone else, Professor Robert Morris at MIT, my friend RTM, who I was talking to recently about this shocking idea that syntax is actually connected to semantics. Very strange idea. I couldn't believe it. We've been so trained to separate them into separate boxes. But the point he made was that operator overloading, I was trying to think, I never read programming in anything except Lisp, really, and so I have to ask people questions like, what are finalizer methods and why do you need them? Stuff like that. And I was asking, why are everybody so excited about operator overloading? Well, it's a lot bigger win to have operator overloading if you have infix syntax than if you have prefix syntax, right? If I need to write if I need to design some special kind of number and write some special function to add them together, I just write, some special plus function. I just call it like any other function. If you're using infix syntax, suddenly it's like the difference between having a nice infix operator and having a function call, which looks very different, right? So I think this is a strange idea, but it's worth keeping in mind that syntax is actually related to semantics, shocking as it sounds.
Okay, Jonathan, fill in the secrets.
Short list, since people have been talking to each other so much. I guess I mentioned one. The programmers, again, this is my generalization of what's going on. They don't care what language they program in, which doesn't mean that it doesn't matter. Let's see, to try to make this quick, one thing on my list is that computers are fast and cheap, and many people haven't really understood this. And I think, speaking of second order effects, I hope. Tell me if I'm wrong, but it's hard to think of languages or maybe even language implementations that have thrived or perished based on how well they performed, right? And I think maybe things were different in the 70s, but I think it's so hard now just to get the program right, get the language right, get the problem well specified, get the prototype done, that worrying about the efficiency can come. You can rewrite the program once you understand it. You can use a profiler to identify hotspots. You can instead of using the free implementation, you shell out for some expensive implementation that has better performance or whatever. But it just seems that I'm looking here. Relate to compilation of dynamic languages. At this point, I don't find the compilation aspects that compelling or interesting. They're important and they have to be done, but they're not sort of the first order kind of problem that we're all facing now. And the last thing is just that object oriented is there's some sort of conspiracy for people to think that that's a well-defined term, and I find it very confusing, and I find a lot of object-oriented programs written in what is called an object-oriented style very confusing. So I think it's that I don't know if it's a secret or a flame, but that there's some sort of deconstruction that has to happen, and the romance with that idea has to end somehow, because it's a solution, it's not the solution.
Okay, we're going to move on to question 4 and start with John Maida. Good ideas that have been dropped, but whose time has now come.
I'd like a Lisp machine with no browser, because every day I waste so much time. But there was something about an idea that you could have a place to think, sort of a camp to think. And those who supervise UROPs know that it's hard to bring your student in with a Pentium 3 when they have a Pentium 4 at home. And so the whole sort of magic, I used to bike here every night actually as a UROP, and it was magical coming to this sort of secret cave with some very unique machines. And that magic is actually quite missing today because it's so commodified. The second thing is, in my role as trying to help the administration in the Media Lab, I noticed a few things, and that is that I was also a 6001 lab TA a long time ago. But I remember when it was sort of fresh and exciting and everyone loved it. And then as I became junior faculty, I realized people don't, once you make a course in the MIT catalog, apparently you can't get rid of it. But it has to stay there forever. And someone's got to tend the fires. And that makes people quite unhappy, it turns out. So I've discovered that perhaps it's a good idea just to bring back the feeling of new courses, new ideas, versus concretize them into things that just no one wants to take care of. The third thing is the fact that all of this goodness of thought space around creating software systems all kind of vanishes when you think about it, right? You make all these comments, you're very funny, and finally it compiles and it all ticks out. You know, only you get your executable. The machine gets the last end, and whereas the human component is missing. And so in many senses, I believe that the sketches, ideas, sort of talking about it, should all be archived into that software system as to sort of increase the value of it culturally.
This is good ideas whose time is now come.
Yep.
All right, good ideas. I thought of three. One of them stolen. Three good ideas whose time has come back. One is new programming languages. It used to be really fashionable to design new programming languages back in the 1970s, and then sort of respectable intellectuals stopped doing it and left it to systems programmers at DEC. But I think new languages will come back, and the reason is related to what I said in the last round, that with server-based applications, you control the server, you don't have to deliver on someone's desktop, you can use whatever language you want, and if there's a language that's more powerful for what you're doing, it will give you an advantage over competitors if you're in a company. And so there's actually going to be users for new languages, and that will give some impetus to people to design them. Number two, I stole from Richard Kelsey, who said it at the last panel, an idea whose time has come back, time sharing, because that's what server-based applications basically are. And so I think, I know that Richard and Jonathan Rees have put a lot of support, maybe you're going to talk about this, am I stealing your idea? Have put us a lot of support for process scheduling and stuff like that right into the Scheme 48 language, and I think that kind of thing is going to be the way to go. Another idea whose time has come back, this is unfortunately in contradiction to what someone has said before, I think efficiency is going to come back, like compilers that generate fast native code. Nowadays you hear more and more about bytecode, like this thing between Microsoft and Sun seems to be developing into this sort of battle of the bytecodes. And to me that suggests that people feel like we have cycles to spare. But I don't think that's going to be true with server-based software. When you have server-based software, you got all these users all sharing some bunch of servers, right? And the servers are going to be paid for by somebody, and the number of users you get per server will be the divisor of their capital cost. So they're going to care a lot about that. You're going to have to be able to support a large number of users per server, and there's just no way around it, unless you want to put software on the client. By the way, look for in the pitfall section when I talk about clients. So I think I/O especially will be fast. I think the reason Sun and Microsoft are facing off over bytecodes is because that's a convenient place for them to insert themselves into the process. They can't control the instruction set because Intel does that, and they can't necessarily design the programming language that everybody's going to use. So if they make the war be about bytecodes, that's where they can get a ground to have their battle. But it may be they have their battle and like everything else just happens on the side because nobody uses bytecodes. That would be kind of amusing. All right, so much for that.
I think I only have one thing to add here that's not redundant with what other people have said, and that's that an idea that keeps getting forgotten over and over again is the idea of, and I'm stealing this from a conversation I had just before air, maybe with John, code analysis, source code analysis and generation. That at one point in Lisp there was this ideal that Lisp was a good language because you could write programs that could, you could write interpreters very easily. You could write preprocessors very easily. You could write programs that understood aspects of certain programs easily, so that if you wanted to, do bulk transformations of source code in some particular way, you could. And this was some sort of ideal, and that got lost in Common Lisp and even in Scheme. I think that if the Scheme report process or whatever had a reference implementation, and if part of the goal was to simplify that implementation, or make sure that the reference implementation was simple enough that it was rewritable, as I said before, so that someone else could come along and instead of writing that interpreter, they could write a variant of that interpreter and understand what it did. If that had happened, the report could have come out better. I don't know exactly what's going on with the various infix languages like Python. I assume Python has some sort of meta-level processing, that the parser is available to programs that want to manipulate Python programs. But my expectation would be that, like most infix languages, it's going to be a pretty complicated data structure. The parse tree is going to take many, many pages to describe, and it's the notion of having meta programs, things that both generate source code and that understand source code, is done as an afterthought. Like maybe in Java. Again, I'm not on top of what's available in Java, but I'm sure that's all there in Java. It's just not. It wasn't a priority in the design of the whole system. So I think that's a very old idea, and it gets forgotten over and over again, even if a project starts out saying that it wants to adhere to that idea. So.
Guy?
Okay, this is right. Good idea to drop this
I wanted to start and say that you actually inspired this question with your Moore's Law talk. You talked about waiting for technology to be ready so that you could solve some game problem that was unsolvable until Moore's Law caught up.
Gee, sounds good. Tell me more.
The Tico talk.
Come back in 18 months.
Actually, I have one item on my list here that actually is of that flavor. Item 1, keyword arguments are good. Call by keyword. Paul's already covered that. I think pretty printers are vastly underrated and can be incredibly useful, not only for debugging, but also just for a quick printing out of data. I'm not talking about just pretty printing programs, but pretty printing data is a good idea. Dozens of times, the Waters pretty printer that was built into Common Lisp has made my I.O. problems a lot easier. It'd be nice if there were a pretty parser as well that is easy to do, but I think parsing is fundamentally harder than pretty printing. I think that pretty printing technology ought to be dragged along in future languages. And finally, I'd like to talk a little bit about rule-based systems, which I think is an idea that got dropped probably 20 or 15 years ago, and its time has come again. And there I think Moore's Law really does make a big difference. Rule-based systems were tried a lot in the early 80s. My wife worked fairly seriously on one called R1 at Carnegie Mellon in the early 80s. And the problem with the rule-based systems then was that the processing power was sufficiently small that in order to get anything done at all, they found themselves having to carefully craft the rules to pass control off to one another. And they found that what they didn't really have was a rule-based system. They had a procedural system that was written in this extremely awkward language for writing procedural systems because they're trying to do it as rules. And I think that now that we've gone for 15 years, so by Moore's Law, that ought to give us how many orders of magnitude? I can't do it quickly in my head, but tons. Computers are surely 100 times faster than they were 15 years ago, if not maybe 200. And so I think we may have enough oomph that it's worth giving rule-based systems a serious try again. They got a bad press because they became associated with the big AI boom of the early 80s, and they made the cover of Time or Newsweek, I forget which one. Now, if you make the cover of Time and it says, this person did this thing, that's great. But if you make the cover of Time and it says, these people are going to do this thing, that's a kiss of death. because then you can't possibly live up to the expectations. And that's what happened and produced the so-called AI winter of the mid-'80s, when suddenly industry was turned off to AI because it was promised that rule-based systems would solve all the problems of the world. And they didn't, and for various good reasons. But that doesn't necessarily mean that rule-based systems are a bad idea. I think it's time to give them a try again.
Okay, we're going to move on to question 5. Then we're going to start back with Paul. pitfalls and gotchas.
Pitfalls and gotchas. All right. Now I warn you guys, there is a pitfall and gotcha in here of radioactive controversy. So don't get too mad at me. So this is not it. Number one, pitfall and gotcha. I think clients are a lose. I think clients. I think client software is a lose. I think designing software, huh? Designing.
Can't hear you back there.
Okay, clients are a lose. Designing software that works on the assumption that everyone will have your client is like designing political systems on the assumption that everyone will just be honest and nice to one another. It would be fine if it worked, but it doesn't seem to. I think what will happen is the opposite. I think there will be this huge proliferation of all these different devices that can access the web. Will it be your phone with a web browser? Will it be your Palm Pilot that turns into a phone? Will it be, some kind of tablet? Will your watch get a bigger screen? Who knows? Well, I don't know, and I don't have to know as long as I just design, as long as all I assume is the software is going to run on the server. I think that will be a nice model for a world in which the other end of the software, the other end of the world vacillates wildly between what the clients are. So I think writing software that involves clients is just going to be a black hole. That's not the controversial one. This is the controversial one. And Jonathan believes this too. We're like this. He said so. We've talked about it. You have to lynch us both. I believe object-oriented programming is, well, I don't understand why it's such a big deal. Actually, I do understand why it's such a big deal, and I think the reasons are wrong. I could see that it's the perfect thing for the kind of application, specific applications where you need that data structure, like Windows systems, simulations of like traffic bouncing off one another, and CAD programs and stuff like that. I don't understand why it has to be the model for all programming. I can see why big companies think it should be the model for all programming, and it's like the software equivalent of having meetings. It looks like work. And so, do you remember back in the days of Fortran programs on Fanfold, where you had like the kind of person who like would write these programs that were like, each piece of Fanfold would have 4 lines of code on it and 30 lines of comment at the beginning with like all kinds of protocols for doing stuff. Well, object-oriented programming seems to be a way to do that, except they're actually writing code and not just comments, right? So something that you might naturally represent as like a list of integers, you get to build all this scaffolding and bustle, where you have all these classes and a whole separate file of stuff, right?
So which version of object-oriented programming are you talking about? Sort of about 40?
Well,
Sounds like
it sounds like the Java one that you're
No, not particularly. Can't get too dragged into a big discussion.
Well, you can drag him into
Why not?
it in the question period.
Yeah, drag me in the question period.
Well, if you say that essentially the classes are formalized commentaries, I think that's almost the best compliment you can make to object-oriented programming. Not the best. It's a compliment, not an objection. You say that all these class descriptions are essentially formalized comment.
But I believe that we're wasting their time. Because they were unproductive big corporate.
It's a great compliment to the system. Instead of being objections, like boost.
All right, I should move on to my next. I think the other attraction of object-oriented programming for people who aren't used to Lisp is because it gives them some of the effect of lexical closures. There are these things called methods, and they're one of 50 different ways of using lexical closures. And these people think, oh, this is so great, I'll use it for everything, because they don't realize there's this underlying idea that they could use in its sort of raw form in 20 different ways, depending on what kind of program they were trying to write. All right, number 3, I think it's a big pitfall to have design by committee, and a lot of people know that that's a problem. I think there's a specific reason that it's a problem, and that is that in many things, in almost anything, risk is proportionate to reward, and I don't think people realize that that's true for programming languages as much as it's true for everything else. To design a great programming languages, you probably have to take shocking risks. And when you have a committee of multiple people working on something, you're going to get something that's with this sort of averaging effect, and you won't be able to do it because whoever thinks of the outrageous ideas won't be able to convince the other committee members they should do it. So you're probably better off, instead of having a committee of 5 people, let 5 different people design their own languages and pick the one that ends up being the winner, and that will probably be better than the one you got from averaging 5 people together. All right.
Okay, Jonathan, yours.
a hodgepodge here, but I guess the biggest one on my list of pitfalls is has to do with I don't know, addictions or arms races or something like that. That we have, people working on languages, and this is I think this has historically been true. There's a feeling that if you just work a little bit harder, if you just add one more thing, if you just did a better job, then the language would be good enough and it would take off and everyone would be happy and you'd solve all the world's problems. There are a lot of things that people in computer science or in languages do that I think are sort of structurally similar to this. They have this sort of addictive nature to it. That people say, if only the implementation was fast enough, then I'd have broader adoption, I'd have better market penetration or whatever. If only, now I guess in a sense these things are true, but what you want to do is to set up institutions that allow all of this richness to grow around the language, as opposed to trying to build in a lot of it. It's always going to be a compromise, but again, I don't know Python that well, but languages that seem to have decent module systems or decent mechanisms by which to grow, right? I mean, you look at Linux with the all the package infrastructures. It's not a good design, but in the RPM at least. But it has allowed all of these things to come into existence and the software base for Linux to grow. And I think, again, not knowing firsthand, I think in languages like Python you're seeing the same kind of thing. One of the key things they did was a module system, and that basically relieves the core language implementers and designers from a huge burden of having to provide everything to everyone, because now everyone else is providing everything to everyone else. That's the only one I want to mention.
Talking about pitfalls and gotchas.
Yes, pitfalls. First pitfall I'd like to mention is poor namespace management. A lot of language is about naming things, talking about things, and you have to manage those names. And if you don't plan for an appropriate namespace management mechanism in your language, things can get out of hand as the language grows. It's very easy to start off a small scripting language and say, oh, well, all variables are global. And then you realize that, well, two different guys want to use I for their do loop, and you're going to run into problems. And it happens at all levels. It's important to allow name reuse, because name reuse is one of the principal supports of brevity, which Paul has already addressed. If you impose a requirement that every name be unique, then you're going to have an unmanageably clumsy language. And if you're going to be able to use renames, you need to do it in a disciplined way, hence namespace control. Access control is also important. Now, in my day, and probably in your day too, it's fashionable to complain about fascist programming languages. They don't let a hacker get at this or that. But it's important to realize that a restriction on one part of the program enables a corresponding freedom on the part of another part of the program. I used to have a summer job back in the 70s at Lawrence Livermore Laboratory, which had very tight security. There are very strict rules about showing your badge when you went in and out and so forth. But once you were inside, you could leave your bicycle anywhere and not worry that it would travel osmotically through the perimeter. So within this very strict structure, there was a certain amount of freedom, at least with respect to bicycles. I've got a couple of complaints about how Java did this. It turns out that Java has access keywords such as private and public and protected. Turns out protected has a very strange edge case where you have three classes A, B, and C. C inherits from B, B inherits from A. B is in a different package, but C is in the same package as A, and some very strange things happen to the rules there. The access control is not well defined in that case. Java subclassing is very strange. If you give another program entity the right to declare a variable of a class, you have given that entity the ability to define a subclass of a class. And this plays havoc with compilers. It'd be nice for a compiler to know, well, here's this class that has 5 subclasses and there aren't any more. But if you simply hand out the name so you can even refer to it, the other guy can make a subclass. So there was a failure to have a separation of concerns there in the namespace management. A third example is Java locks. If you have so much as a reference to an object, simply so you can call one of its methods, you have the ability to lock it. This is bad. Locks should have had private and public keywords as well, and they don't. So it's important to be methodical about access and security. Another pitfall is to be sure that your language will parse. this seems stupid. If you just sit down and start designing constructs and don't worry about how they fit together, you can get a language that's difficult, if not impossible, to parse, not only for a computer, but for a person. I use Yak constantly as a check of all my language designs, but I very seldom use Yak in the implementation. I use it as a tester to be sure that it's LR1. Not for the sake of the computer, but because if a language is LR1, it's more likely that a person can deal with it. Finally, I strongly recommend big num and rational arithmetic for dynamic languages. Sticking with 32-bit ints just leads to too many pitfalls. You can't even negate a number and be sure the result will be positive. I mean, this is nuts. So sometimes you need the mod 2 to the 32 arithmetic, make that be a separate type or something, but for just ordinary general run-of-the-mill arithmetic, the overheads and inefficiencies really aren't all that bad, and the gain in programmer productivity is really well worth it. Have big nums and rational numbers.
Okay. John?
Let's see here. I think one pitfall is the common conception that we think everything's getting better. I think that there's I actually made a book called Design by Numbers 2 years ago that introduces a new kind of a very rough language to teach designers how to program. I actually was going to make it how to teach Java to designers or C to designers, but I went to the COOP and got Visual C++6 and installed it, and I couldn't get Hello World to run for half a day, so I knew there was problems. So I started building a special language for that. But since then I've been thinking about the fact that it's kind of like all of us are kind of looking for that kind of Suzanne Summers diet, you know, that kind of like, what's the latest, this language will save my life, you know, if I compile it. And I think I hit the wall last time when I installed OS 10, and I realized, oh, this is just next step. And I was like, just totally shocked. So I'm depressed about that. Another thing is that, one thing at least I believe in is that we have to build sort of self-destruct sequences in all languages we think about. Because people start to sort of build a community around it, they start waiting for version whatever, 2, 3, 4, whatever. I think if you build it, you know, they'll come, but if it flies, let it die somehow, because then you can always stay free and thinking beyond. The third thing is that democratizing programming. Everyone should program. I've having recent experiences in the Media Lab. I've noticed that all the administrative assistants can program in Java now. And I used to think, you know, assimilate it. But then I actually realized this is actually kind of an issue, and that is that I see my kids learning typing in kindergarten now, and I wonder they'll get RSI like me. So I'm wondering what is a different model of programming that's more humane. I'm curious how to sort of see that happen.
Okay, that ends the first part of this panel. We're going to move on to the question period, and we want to give preference to graduate students this time. So, Doug?
Should languages with algo-like syntax have macros instead of being procedural?
What do you mean procedural?
As opposed to pattern matching, or that you have the full algorithmic ability of the language to implement the macros.
If someone needs that and it's not in the language, they're going to do it through some other route. Right? So the question is, how do you want people's programs that are actually doing, you know, macro expansion or program manipulation or language extensions, how do you want those programs to look? Do you want it to be a separate program that's doing a pre-processing step, or do you want it to be somehow integrated with the underlying language? I think it's a hard question because, I mean, yes, it seems good that you want a feature like that, but it's very complex because and the reason it's complex is because you started with a language with a complex syntax.
I'll comment further on that.
It has been tried. Yeah.
There are different kinds of so-called ALGOL-style languages. There are some in which statements and expressions are not particularly differentiated. I'm thinking, for example, of the Bliss programming language. There are others where a fairly strict separation is made between statements and expressions, such as C and Java. And in the latter sort of language, if you want syntactic macros, you should think about having macro calls that all also fall into those categories. One of the things that makes C macros often so awkward is that the macro calls look like expressions and not like statements, and to make C macro calls that behave like statements, both semantically and syntactically, is actually fairly difficult. And so one would want to design a macro mechanism that makes that smoother.
I know there are several papers within the last 5 to 10 years on this subject. So Daniel Wise worked on this at Microsoft, and there are others.
Dylan got macros?
Dylan has macros, yeah.
Yes. Okay. Then how they did macros in Dylan ought to be looked at more closely, and I should do it too because I don't have it swapped in right now.
How important do you think it is for a language to have macros? Do you think it's kind of a nicety, or it's really an essential feature if you want to grow a language? Like you can last and
For me personally, I can't program in a language that doesn't have macros. I just can't make myself do it. I end up doing outrageous things like, going to work for any company that will hire me to use macros. Or, if they seem like they're going to go out of business, start a company myself. We'll let me program in Lisp.
If a language doesn't have macros, I find myself, in effect, using them in my pseudocode and then hand expanding them, and as a result getting code that might be somewhat less maintainable because some of the abstractions aren't apparent anymore.
Yeah, I find if a language doesn't have macros, I write a preprocessor for it that does what I want. Not necessarily implementing macros, but doing what I want for a particular application.
Jeremy?
In terms of language design, do any have any commentary on the role of the development environment that accompanies the language? Most of us here, I expect, still code in, GCC and debug with GDB and maybe run it all in Emacs on a good day. What is the role?
What with that?
Well, maybe nothing, but what should be the role of the development environment in, when should that be thought about? How should that affect the design of the language, and vice versa?
Profilers.
Plastics.
Spend half the time you would spend making the compiler fast, writing a good profiler instead.
I was more thinking of sort of the user interface end of things.
And you want things like who calls and who defines this method. These are sort of basic grep-like things. Emacs plus grep plus a few things that you write in eLisp is very close to being a sort of halfway decent. Is very close to being at least as good as any sort of GUI-based IDE I've ever used.
Well, so here's my specific case. An argument I've had is I claim that one of the problems with S-expression syntax is that there's no syntactic differentiation for semantically different constructs. If looks just like a procedure invocation in terms of the perennial. And when I've had this argument, one of the responses has been, well, you should just be in a development environment where it highlights these distinctions in some colorific way. Does this make sense? Can you consider the development environment as part of the language? Should you consider the development environment as part of the language when thinking about things like human interface?
I would say yes. My experience is that the more what's the word I'm looking for? Featureful the IDE that I had to work with, the more productive I can be, provided it doesn't get in my way. On the other hand, I've been used to using stone knives for the last 30 years, and
right.
I can easily slide back in that mode, but maybe that doesn't mean that I should settle for it.
Just thinking about Lisp, I'd find programming in Lisp very difficult if I didn't have paren, paren, the bouncing paren, and if I didn't have, completion of long names, things like that, basic stuff that Emacs just gives you. And maybe if I was forced to program someplace that didn't have those two features, the language I would want to use might look very different. It might be
short
Python.
Names.
Might be Python. I might use short names instead of long names. The language might have short names instead of long names. So there's some relation, but
tools that help you see the structure of your program can always be very valuable. For me, the number one thing is just being able to get reasonable indentation so I can see the basic block structure of what's going on. Anything beyond that is wonderful. Being able to tools to help you cross-reference, to be able to trace and profile, those can be very helpful.
So should indentation have semantic significance?
It does. When I read programs, if the indentation disagrees with the parentheses, I don't notice. I read them by the indentation, and in fact, that's how I notice when there's an if in a program. I notice by the indentation.
So I would agree. The indentation should be significant, but perhaps it should be a redundant indication of significance, and it's worth having it checked by a good IDE.
But I want to sort of point out that the IDEs are so complex now that they break so easily. Like I had a bad problem with the latest version of CodeWare where I bring up find and the whole thing goes down, and your whole faith just goes away. And that really changes the way you approach that. I'm going back to stone knives, actually.
Maybe there's something to this, because I notice a lot of programmers, I talk to them and they sort of shamefully admit that they debug using print statements instead of whatever fancy debugging environment they have. I will come out of the closet. I edit programs in VI. I cut and paste them into a browser, into the top level, right?
Which I will admit was the one really awkward thing I found about using Haskell for some programming, which was it was hard to drop print statements in because it's purely functional.
Right.
Otherwise, it was fabulous.
Yeah. And I debug using almost exclusively print statements.
I've never had the batteries die in my stone knife.
Okay, Sam?
Speaking of functional programming, this is mainly for Gaito and anyone else who wants to comment. I'm interested in how practical you think that purely functional programming languages like Haskell or any of the other similar languages, how much monads can be applied to it, and how much do you think they can be applied to regular real-world programming, like programming tests?
I think they're perfectly capable. I don't have the references again in my head right now to give you off the top of my head, but some substantially large applications have been programmed in Haskell and going beyond just the compiler.
It requires some retraining.
So what's preventing retraining, but what's preventing it from being used more?
It is a sufficiently different model from the usual way, but with the introduction of monads to support side effects, it really is this wonderful thing where you can sort of open your left eye and it looks like imperative programming, and then you shut it and open your right eye and you say, oh well, there's a functional explanation for it, even though it feels imperative. And maybe that just makes you feel better psychologically about using assignments and print statements all over the place.
Is there anyone else who's on the panel who's...
I think I concur with that. I mean, the monads were a good development, and they help blur the distinction between functional and imperative programming. So.
Okay, I'm going to stick with the grad students while we still have questions.
I just want to pitch into the grammar question. I'm kind of surprised by the response about the support. There's a lot of building use of support tools out there, like not just the actual block, but you guys would use dynlang or Saber for a couple of examples to see the cost.
I heard great things about Saber. I never used it.
It made your orders and management faster, programming. You didn't have to worry about where your object file was. You didn't have to do these things. And I'm sitting here like 15 years later going, why am I wasting my time trying to remember where I left my object file when a tool did this for me 15 years ago, and we still have nothing to happen. So I think that's something that's been neglected badly.
Yeah, absolutely agreed. I've done a fair amount of programming on Macintoshes.
Wait,
for example,
can you repeat?
Sorry.
Summarize.
Summarize. She says that a good programming environment, such as, for example, the Saber environment, which was popular in the late 80s, makes you so much more productive because it keeps track of stuff for you. Particularly, you don't need to remember where your object files have gone. It just takes care of a lot of bookkeeping and makes you so much more productive. Why is that not now universal, I guess, is the question. And I agree. I think the main thing is that it's possible to do with the stone knives, and you can get something out the door. The IDEs take more work to produce to make them good, and so they tend to come along a little late. But there are very good IDEs. On a Macintosh, I've used the Code Warrior development environment, for example, as well as the Symantec ThinkC 10 years ago, and I found my C programming much more productive in that environment than it would have been using Emacs and CC.
Okay, any other grad students? Get in.
Here's your opportunity.
Okay, you want another question?
Sure. Should ASCII be the program representation format? Should we consider doing something saner? Not that I'm British.
Do you mean Unicode?
Sure, Unicode text. Should text be the representation, or should we think about storing programs in some lightly compiled format and then being able to represent them in text, indented according to your preferences and with comments on or off?
Are you asking whether programmers should have complete control of the layout?
I think, well, you could look at it like that. But the question is more whether if I get your code, can I trivially reformat it the way I like?
It's more the abstract syntax or just
Control on a queue.
let's ask whether programs should be thought of as being represented as a linear sequence of anything,
Yes.
as opposed to being some more complicated structure. On the other hand, people seem to deal well with 1- and 2-dimensional layouts, and at least it provides a basic structure that's easy to understand and hard to screw up. A piece of me would like to see Unicode. A part of me is afraid of what people would do with it. I think I might settle for ISO Latin 1 plus the 2000 code page of Unicode, which has a lot of the technical symbols. I'm not sure that I feel an urgent need for the Serbo-Croatian alphabet in doing my programming, but perhaps someone in Eastern Europe might disagree. Hey.
You get so many more characters.
But are you talking about something like the small talk environments from the 70s, where the code really is stored as almost as compiled stuff, and it's brought up very dynamically, and
That's
really
sort of
only
what I'm
lives
thinking
inside
of.
of data structures. Really lives only inside data structures inside of effectively a persistent process. My bias is to think of, I would like to have at least the option of having programs be, represented as documents somehow. I'd like to be able to publish them in a book or something. So at least you have to be able to extract a linear representation of the program. And yes, it would be nice to be able to put pictures in the programs. It might even be nice to be able to put diagrams with boxes and arrows and call that a program somehow and have that interpreted. Put some meaning on pictures. Am I going too further than you wanted to ask about? But the thing is that the kind of support structure you would need in order to make that kind of thing viable, I think would just be so overwhelming that it would kind of topple under its own weight. Now, I'd be glad to be proven wrong, but it contradicts, my claim that programming language implementations should be rewritable. So that's why I have a little difficulty with it.
It might not be that hard to write a compiler that takes in, say, FrameMaker files or Adobe Illustrator files and things like that, and has specific environments that are defined that it goes and looks for. And when you say, let A equals this picture, it's not that big a deal. Mostly just being able to embed all these different data types within the structure of your program text and assign a meaning to them.
So, yeah, give it a try.
Before we go on, I just want to say it's 2:30 now. If the panelists can stay, we're happy to go on for more time and open it up to more questions. But if you have to leave, we understand. So, Mike, you're next.
Given the commercial importance of software to the whole world system, it's kind of surprising that venture capitalists don't want to sort of see programming advance to a state. I think it's interesting that the companies that are going to be producing the languages may not even say that they're doing a language. For example, BowStreet.com, they got $140 million of venture capital money talking about dynamic business webs and all this stuff, and what they're really doing was doing a programming language environment, but they didn't know it. But that was the way to sort of feed it to people where they didn't see that it was a language, it was something else. And so that's kind of a technique. How do we get the good languages out there? Maybe it's that we don't say that they're a language.
You don't need VC.
Yeah.
People seem to develop languages just fine for free.
Well, yeah, it's a funny situation. I mean, the people who know the history of programming languages over the last 30 or 40 years, 40 years, will they'll say huge amounts of research money has been poured into the problem of improving productivity and coming up with good languages, and nothing has come of it. So we're not going to put any more money into that. Let the people doing Python or whatever solve the problems. Let the free software folks, basically all of us and whoever, fix the problem in an organic way. But there's no money in it, and there's no good sort of argument that that it's even possible to increase productivity. So that's the way I see what's going on as far as the funding situation goes. But and then as far as all these companies that keep getting funded to do programming language research and do programming languages, that's just people who are good salesmen and funders who don't know the history. So sorry, I'm a cynic, obviously.
I have a question about the embedding of programming environments within social environments, and it's sort of has to do, I think, with something everyone in the panel has talked about at one point or another. The company that was just good enough to lay me off had a wonderful sort of visual editor for a rules-based system that involved something terrible in server-side programming. But the thing is that it allowed a manager using a little picture-based editor to write a set of rules, and then at that point we could change the underlying structure underneath, could write it in a different language. We're using Java now, or quote-unquote we. But the manager would have that environment, then a coder could go in and start changing text files. And so the thing is that each person at a different level had a different picture into the system that was being built. So the manager was able to sketch something out, the coder was able to handle special cases, boundary cases a lot easier. And I'm just wondering to what extent is work being done in this so that people who don't want to program, and probably are better off for all of us not programming, can get some sort of initial input, and then that can be carried on through the whole cycle. Are people looking at this?
John, that sounds very productive, actually. I'm not aware of that kind of area.
Because we've got the social system as well as the information system.
Any other people?
Which I knew. Seems to me that what a lot of people want is a magic wand, or the genie in the bottle, which is this thing in fairy tales that causes something to happen that makes you happy without you having to think about the details of what it is that you want.
Well, in this case, it's someone who's waving a wand and then, says what they want to happen and provides a sketch for it, and then people...
And then dozens of magic trolls make it happen under the table where you don't have to see.
Yeah.
Programming is work, I'm sorry.
Yes.
So I have, just for private reasons, I have a fun interest in music and electronic music, and recently I learned about the C-Sound system that actually comes from the Media Lab. And what the C-Sound system really is it's a compiler which takes a programming language and produces a sound file from that programming language. And actually, if you're interested in studying programming language, it's a very interesting programming language because it has this organic feel to it. But my question to you, in relating it to the dynamic languages seminar right here, is the fact that what people want to do apparently is do performance. And so they want to have a lot of computing processing power at their hands, and so they can do all the thing in real time. So my question is about making these kinds of systems that are producing music dynamically change as you're going along. So the idea is you're having musicians make some input to control these things, and they want to change things like algorithms, in fact, things like that. So I guess, so how much work have people been doing in actually applying the techniques of dynamic programming language and warping those kinds of codes to the performance aspects of things? Has there been a link there? Trying to
You're more the expert than actually.
Okay, I'll take that one. Well, there's a graphical programming language called Max that has that aspect, although it doesn't have the power of textual programming languages. There's work at CMU in that area. There's work with the Squeak Smalltalk open source project that allows you to generate music on the fly and modify it. I'm not aware of anyone that has been able to do both the high-level scripting and the low-level DSP in the same language. So that's the sort of, I'm actually interested in doing that.
Of course, it's really real-time dynamic programming, which is, this is a particular instance of it.
What about the composition?
Right, that's where Max came. Right, did you want to say what?
Oh, I didn't know if you knew about.
Yeah, actually I do. I worked there at Aircom, but in terms of real time, it was mostly just Max. I mean, it's hard to get the GC latencies down and such like stuff. If you want to have dynamic language, you have to
do it during full notes.
Yeah, you have to work on that. And I think there was some work where you just turn off the GC and managed to get your performance out without running out of memory. But anyway, CMU is working on that problem as well.
Something you might want to look at in the area of computer-supported performance is that Korg has a new synthesizer out called Karma. There's a review of it in the latest Keyboard magazine. And reading that review made me itch to get a programming interface on the front of it. But it's proprietary, and I think it's sealed off at this point. But it's a very interesting looking system where, in response to your MIDI gestures, it tries to think of other things that would go along with it. And that makes it sound a little bit like Band in a Box or, one of these sound jam things, but apparently it's gone a large step beyond that. It's worth taking a look at.
Okay. So let me make this a little provocative. You guys sound like you're living 10, 15 years ago. And as if the way we actually wrote programs in the real world is the way we teach them in 6001. Namely a well-defined base, and you build up from that. But in fact, my experience recently is that people don't write programs, they cobble them together. So for example, I'm teaching a medical computing course. One of our students gave a presentation this morning of a project he had done for the course in which he took something that is able to take an HL7 data stream and turn it into XML, and then he had some XML parser that was able to interface with some design environment in which you could map it into a relational database structure, and then he had something else that stored it in Informix and something else that pulled it out of there. And of course, these things are all implemented with no rationality whatsoever. They have bizarre APIs, if any, that are written in different environments in different languages. And the hard part of doing all this is not the 150 lines of code that he wound up writing, but it's figuring out how to glue this god-awful mess together and how to make it even slightly robust enough that when one of the pieces that he doesn't have control over feels over dead, his whole thing doesn't feel over dead. And I don't see very much support for that style of programming, and yet that's what I see a lot of people doing in the world now.
In some programming environments, again I'm thinking the Macintosh because I'm familiar with it, some of the high-scale applications actually go to a great deal of trouble to make themselves scriptable and provide a programming API so you can, for example, you can write programs that tell Illustrator what to do instead of using mouse clicks, that kind of thing. And to some extent, those things can be pulled together with AppleScript and made to work in a reasonably smooth manner. But I agree that a lot of other applications are built with no thought whatsoever to a programmatic interface, and you just have to cobble together, try to pretend you're a person and make the gestures. And it's awful.
Pete, what would constitute a solution to this problem?
Hey, you guys are the panel. No, it's just striking to me that if you ask me where am I suffering right now from a lack of solutions in the programming arena, it's in this type of environment, and not that my Lisp is perfectly fine for doing the things that I've been doing with it for 25 years.
I wanted to just say one thing. One of the panelists who was unable to come today, Mike McMahon, started a company called Oberon, and they're specifically addressing gluing together these complicated libraries and making them work with graphical programming. So you might want to look at their work. Greg.
This is it's historical dynamic languages design question. I don't know if anybody on the panel was there. I heard that when scheme design, either for R4 or RS, I guess, the discussions that led up to that, there was an agreement that decisions would be made by consensus, and if they couldn't be made, if you couldn't get consensus, then they wouldn't make it in. And heard that really slowed down the adoption of anything slightly ambitious. So the question is, was that true, or is that just urban legend, and what might have been in scheme if that hadn't been adopted, and just if anybody was actually there, if they had any comments on that process.
As I remember, starting in when the sort of committee started doing its stuff, the agreement was that decisions basically had to be unanimous, right? I think that's how it went. So it wasn't just consensus. If there was one person saying, no, this record package is terrible because I think, and then they go into whatever. It's surprising that anything got done at all, but I think those were the rules, and when whenever you set up a committee, you basically can't change the rules from the point the committee is set up, right? So.
Well, were those good rules or bad rules, and how, if they change, how would you change it if you?
I think at the time, for the goals that were there in 1984, they were good rules. I think that that structure may have started having problems, in the late 80s, and it's basically at a standstill now. Nothing can happen at this point. Sorry, I shouldn't have said that.
Is this the official view of the committee?
No, this is a purely personal view. But
What's
so. I mean, there were certain things where it seemed like there was sort of one or two people who were holding out. They had very definite philosophical objections to the way features were formulated, and then, but nobody else wanted to adopt their formulation, and so everyone who's followed this knows what these things are, and that's just sort of the way it happened.
It's also worth pointing out that Scheme at that time developed in the context where there was an alternative. People who really wanted a version dialect of Lisp with explosive feature creep had Common Lisp to turn to.
Remember, the committee was formed with the express purpose of allowing the 3 or 4 groups, geographically separated groups, to read each other's code. Had nothing to do with executing code. Had nothing to do with standardization or anything like that. That was its only goal. And so, the group wanted to form, wanted to set up a little community on that basis.
It's worth pointing out, actually, that's the original goal of Haskell, for example, as well. Was simply so that everyone could read each other's papers.
If you look in the preface to Friedman and Springer's Scheme in the Art of Programming, I wrote a foreword for that book, and as part of that I did the exercise of looking at the standards for a dozen different programming languages and merely counting the number of pages in each standard. And interesting enough, at that time, about 10 years ago, the two ends of the spectrum were bracketed by Scheme and Common Lisp at 50 pages and 1,000 pages. And interesting enough, Dieball and Cobol were the next ones in. And then you had the algebraic languages in the middle. So take that for what it's worth. Pardon?
What was PL1?
Which PL1?
PL1 was somewhere in the middle.
Language is large, but the spec was small.
Was any of that a function of poorly or better done documentation?
Oh, absolutely. I mean, take these numbers with a big grain of salt, and they're only within a factor of 2 or 4.
Okay.
But still, it was interesting that the Lisp people had alternatives at each end rather than being close to the middle, and there was value in that.
Yeah.
My question is, I thought it was very interesting, John's comment about artists being interested in coding, but coders maybe not being interested in art. And I was thinking about it, and maybe the artists see it as like another way of expressing, another tool to like express their art. But I found that like many people who are like really, really crazy hackers, really good hackers, are actually very artistic, and they do lots of things. So there's lots of coders, and some of them are artistic. And I think this pool of people is maybe the more artistic side.
And well, that's sort of a point that I've been trying to make at MIT, actually. It's actually quite hard. Because at MIT, art is supposed to be a pansy activity, where you take a break and paint or something like that. And so it really is an issue of how do we view artistic practices in the technical domain. And perhaps the next 20 years something will happen where people who are at this sort of strange hybrid state can have a kind of a credibility more than anything else. But I'm waiting for that, actually. It takes time.
Art is something that gets declared in retrospect. Leonardo got paid the same amount for painting his paintings as the people who made the frames did for making the frames. Back in Leonardo's time, it wasn't considered nearly as prestigious as his work is now considered. And I wouldn't be surprised if the things... That's true. They had really good frames. But still, if you were going to invest in one or the other, I would have invested in the art rather than the frame. I wouldn't be surprised if the stuff people are cooking up right here in, a couple hundred years from now is considered to be the cool thing that was being done now. I mean, whether it's called art or not, who knows. But I actually studied art. I studied painting at RISD for a while, and I can tell you, people in the programming languages world are working a lot harder and they're a lot more imaginative than people in the art world.
What other languages are there out there that have particularly interesting design features, or that you think would be worth looking at the design of just for enlightenment?
The question was, what obscure programming languages out there that perhaps have particularly interesting design features that deserve to be better known? Is that an adequate summary? Okay.
The Lisp that was originally described in McCarthy's paper in 1960, I recently went poking around in that, and it's really actually very cool to see what, I mean, it's a language that was produced not by someone trying to design a language, but someone was just trying to axiomatize programming, and that's what you get out at the end when you try and have a few axioms and try and make this language that you can sort of write everything else in. I know that's not what you expected to hear.
Any other panelists?
I can think of three things sort of apropos to that. There's a language design effort going on now for a distributed, secure scripting language, basically, and it's at ewrites.org. Language is called E, and they're going for popularity. If you're interested in distributed scripting, then you should go there. It's very nicely integrated capability, distributed capability security. I think category theory is a great language. It should be part of any language designer's repertoire. And but I really think of it as a programming language. It's not a part of mathematics. It's a notation. And for some reason, your question made me think of a document that I reread recently that I had sort of forgotten about, and I think everyone should look at, which is Perlis's programming epigrams. And if you haven't looked at those, you should do that. But probably if you do a web search for Perlis, P-E-R-L-I-S, and epigram, you'll find it. But just wonderful set of principles for programming and for languages.
Many of the most interesting programming language designs to me have actually been based on some piece of mathematics that's interesting in its own right, and it might be embodied in a programming language in a different way, and might be worth looking at. For example, APL has been mentioned a couple of times, and APL is largely inspired by linear algebra and generalizations thereof, looking at both structures of data as well as the way operations interact with, and you can combine matrices in interesting ways. Snowball, which is really sort of an embodiment of regular expressions out the wazoo. That's had another one in mind.
We got to think of some from the 90s at least.
I think there's value in going back and looking at earlier designs that have interesting, quirky features and trying to figure out what parts of them are worth saving and why those programming languages died or didn't make it in one way or another. Prolog, yes, based on essentially a particular way of using logic clauses, horn clauses, to express programming languages, and the implementation one can argue about and whether chronological backtracking or other kinds of backtracking the right thing to do, but the idea of using logic as a programming language is pretty interesting. Let me also mention Tico, which we think of as an editor, but it's actually a very peculiar programming language which is based in several ways on finite state machines. Both in its program interpreter, you chunk on one character at a time, and each character is a command, by golly. But it also had ways of defining sub-finite state machines that would process the text in various ways, at least the MIT version here. I guess that'll do for now.
Yeah, we're going to take just 3 more questions.
Well, I think you've been talking quite a bit about past programming languages, and we are not yet sure about what the future of computer science is going to be like to teach programming languages to undergraduates. I'd like to see that. I've actually thought about it quite a bit and have never been able to answer the question very well. And you've mainly been talking about the past rather than the future. What can we do in the future? And can you write something that relates to what you talked about that will help us do good things in the future about teaching programming languages to undergraduates?
But, sorry, teaching programming languages or teaching programming?
No. We assume that we teach programming.
Okay.
To teach the quality of programming languages, the fact that programming languages were very widely appreciated. For example, Perlis is Turing Award was related to his programming language work. Many people received awards because programming languages were a very good topic, and now they seem to be somehow in between. And can we return the field so that it will be as important in the future as it was in the past?
Well, the ACM is recommending against spending time in undergraduate curriculums,
That's
curricula
right, yeah.
on programming languages. They think it's a very peripheral subject. So times have sort of changed as far as the prestige of the
Yeah,
subject.
but maybe you can do something to change what the ACM is saying.
Are you talking about programming languages or programming?
I think he was talking about teaching the art of programming languages as opposed to the art of programming.
I'm not sure that programming languages should have the prominence that they had 30 years ago, much as I love them. It may be that programming languages are like jazz, or perhaps they're more like ragtime, that had an important place in history, and it's important that people still study it for how it will feed forward into the future. But it may be that the thing of seeing 50 new programming languages announced per month or per year, it may not be a healthy thing in the future. I think it is important that we understand language design principles, and that a few new languages be designed so we don't overlook any possibilities. But we may be settling into a period of relative stability, let us say, and that may be important to form a solid platform for moving on into other things in the future. If I were having to learn a new programming language every month, I wouldn't get much done in the way of applications above that level.
I think you're absolutely right that the question of how to teach what really needs to be taught in that area, even if it's only 5 undergraduate course hours in a bachelor's degree or something, I think we don't know how to do that. That we haven't distilled the ideas properly, and I mean, I spent a lot of time trying to do that at the course in MIT, and I think we didn't do a very good job. And it's very hard to kind of crack this intellectually in a kind of nice, parsimonious way.
It's important to teach it, but it's also important to realize that not every graduate we turn out will become a language designer.
I think it's also an issue of need. I did some experiments in Japan around 7 years ago in design schools to try to get to create a program where there'd be more computation into the curriculum. And one thing I started doing with the sort of a first-year class was I'd have one student sits down and the 3 students stand up and they become pens. And this student has to draw a picture, of course not using their hands. And so they would devise this whole sort of method of drawing onto the canvas without their own hands. And we did exercises of designing languages to support that activity, and sort of did that over a few years. But that was a need for that there, I think, and that was relevant there. But maybe now it's need is different.
I'd like to make one more follow-up, which is I would now like to turn around and contradict myself and comment that according to another talk that perhaps some of you have heard me give, I believe that every programmer is a language designer in the sense that as soon as you've written 200 or 300 subroutines, you've made a big enough vocabulary that you are now working in a new language. And you may want to give some thought as to the structure of that language.
I think programming language education, you can think of that partly defensively, right? You want as many people as possible to have experience and good ideas about programming language design, because so many of them will be designing languages that you'll have to suffer with later, right? So, I mean, it's easy to think of examples of that where people just made languages, they were just uninformed, right? Because they didn't learn any of the history or any of the concepts, and now you have millions and millions of people and billions of dollars invested in terrible languages.
One of the most valuable parts of having done CS undergrad at MIT were the classes that were kind of language agnostic, and where I could do one problem set in Common Lisp and one in Java, maybe one in C++, limited time or whatever. But it's hard to get a lot of people to take advantage of that because, I mean, and I was only kind of within commodity languages if you include Common Lisp and Scheme in that, but it's hard to get students to do that by choice. And people I've met from other kind of top universities just never had that option.
Any more questions?
Yeah, I want to push back on Paul's comment about clients being a lose. Don't you think, though, over time that it's inevitable for economic reasons that more code is going to be pushed onto the client, both because the cost of putting stuff on the server is very high, also because there's going to be a lot more unused power on client machines and not on servers, and also because of latency. Latency is not going to be improving over the future.
It would be fabulously convenient, just like it would be fabulously convenient if everybody would be honest. You wouldn't have to lock your door, you wouldn't have to buy all this lock hardware or carry around these keys and credit cards and stuff that you could lose. But, you know, that's just not the way the world is. I think, you know, if you had some sort of if you were the Soviet Union, right, and you could just tell everybody what they were going to have on their computers, then you could make this happen. But it's hard to see how it would happen today, even if Microsoft tried it.
Yeah.
You're already relying on this right now.
All I would ever dare assume is that you can show HTML pages and that forms work. And even forms might not necessarily work. I mean, certainly wouldn't assume that JavaScript works, for example. It seems like people who write software that depends on JavaScript are always 85% done. You know.
But HTML is ubiquitous, and at least once a day I download some page that crashes my browser. And switching to the other browser doesn't help, always.
If something is a big enough win for everyone who implements it, then you don't need central planning to tell everyone to do it. If there's something that, you know, some sort of protocol negotiation sort of thing that could be on every client, it would find its way onto every client, or at least all the popular ones eventually. And, you know, and you can write the server so that it doesn't assume that it's there, but if it is there, it can give you a win.
Well, a new client means a new protocol, right, for talking to the server. New protocols just don't get invented that often. There's like sendmail, and then 20 years later, HTML and HTTP. And, you know, the next one's due in another 20 years. Maybe that will be your client.
Using HTTP.
You don't need new protocols.
I mean, you rely upon all kinds of things on people being on client machines. You expect everybody's got IP now, right? I mean, eventually things end up on the client, and enough so that there's an economic reason for you to assume it's there.
There's sort of a spectrum, though, right? I mean, most of us have browsers that support to some extent JavaScript, but I'm probably not the only one in the room that hasn't downloaded the Flash extension and just ignores sites that require it.
That's true. My main point is that when you're running a site, you have to pay for your servers, you have to pay for your bandwidth, and that costs money, and we've seen a lot of companies go down in the last couple of years for this exact reason.
Sorry, go down because of bandwidth costs?
Because of
the bandwidth costs,
because
the
of their
operation costs are
of
too high?
operation costs, yes.
We got time for one more question. Yeah, you're here.
So you've each mentioned some aspect of dealing with huge amounts of information, organizing information, presumably the web. Can you comment on the relationship between library science and languages for expressing data, XML, for example, or metadata, compared with languages for programming, particularly dynamic languages, and should they be different things, or is there a continuum, and how do they relate? Are there features of dynamic languages that make them particularly suitable for dealing with information and meta information in a distributed system?
Libraries have to be very conservative, right? I mean, about what they do. So they want stability in data structures. They want stability in protocols. So I think there'd be a big tension between. I'm not really qualified to say.
You raise an interesting point, and I agree that it would be an awfully good thing if librarians and database designers talk to each other more than they have historically. But since I'm relatively unfamiliar with library science, except for knowing that it's a good thing,
librarians, they have to be extremely conservative. They're trying to make sure that their information is going to be readable in 500 years, right? And as far as librarians are concerned, there still isn't a digital archival medium, right? That's an extremely basic thing that they're missing. If someone who's worried about that is not going to want to talk to you about dynamically changing your XML schemas and things like that.
But each of you did today mention something about problems that were sort of in that area.
That would probably be different from librarians' problems. That would be companies' problems or individuals' problems. So, sorry.
Okay, let's thank the panelists.